So whatever exam is your next exam, and that is chemical kinetics coming, or the syllabus is solutions?
So basically, right now I've finished my midterms.
Okay.
So my midterms were in September, and now we will be having directly pre-boards in mid to end of November.
Oh, and in pre-boards, the whole syllabus will be coming, right?
Not really, because all the syllabus is not completed in chemistry for us.
Okay. So, do you have the syllabus for like chemical kinetics will be coming, right?
Yes, it will be
Yes,
coming.
we can start that. Okay. So you have let
Also,
me
ma'am,
yes.
after this, I have difficulty with solutions as well. So maybe
Mhm.
after chemical kinetics, we can like do like a revision of
Yes,
solutions.
we'll surely do the division of solutions because solution is a good chapter and it
Yeah.
is an easy chapter. I'll say class 12th chemistry is somewhat easy as compared to 11th. You won't be getting any problems. Okay, tell me, we have done half life of zero order. Sorry, you have done up to half life of zero order reaction. Let
Yes.
me see where is it.
And
This
then
is
we kind of started on the integrated rate equations, but we weren't able to do it
complete.
fully.
Okay, integrated rate equations. Okay, so so do have you done all the derivations?
No, ma'am.
Okay, so uh, derivations are asked in the exams.
Yes.
Yes, they are asked.
The
Yes,
derivations for the half-life or the integrated rate equations.
yes. I'm just asking ki, since it has been a long time since I've given class 12 exam, so I really don't know ki in boards are the derivation asked or
Sorry, ma'am.
it's okay. Priti, what I'm saying is, let's first quickly revise the solutions. Because chemical kinetics, I have one time I have read the solution before coming to class. I have just quickly seen the solutions
Okay.
chapter, so it will be easy for me to explain to you. In the next class, I'll try to finish the solutions in max to max 2 or 3 classes. Because you don't have to really learn it, you just have to take a quick revision. So I'll finish that, and after that we'll start chemical kinetics. If
Okay,
I'll
ma'am.
read once, then it'll be easy for me to explain you. See, there is no problem for me to start that chemical kinetics, but it would be better for you only if I read one time and then I'll explain to you.
Okay, ma'am.
I really don't have any problem with that, but since it is a bit like see, derivations are just for boards only, right? It इतना याद नहीं रह जाता for the time. I only have
Yeah.
learned the formulas. I really don't have a good now a good command on derivations. So we can start with the solutions. And
Okay. Also,
in the
ma'am, sorry for joining late. I'm so
it's
sorry for
okay.
joining.
It's okay. It's okay. Acha, are you comfortable in English only, or you can speak
Yes, ma'am.
both the
You can
languages?
explain a little bit in Hindi. I can understand, but mainly I
Okay.
prefer
So
English.
okay, I'll explain in English only. But if sometimes if I go flow me, if I go in Hindi and you don't really
Okay.
understand, you can just tell me. Okay.
Okay, ma'am.
Yes. So basically, starting with the unit one, that is solutions. So in solutions, see, I'm just giving you a quick revision. I'm not explaining you. I'm I'm not going like that. I'm just going a little fast. You have already learned this chapter, right?
Yes, ma'am.
So basically in this chapter, we'll be dealing with solutions. Solutions are homogeneous mixture of two or more components, right?
Yes.
Homogeneous mixture means that the components that are mixed, that are uniformly distributed into each other, right? Yes. And in this particular chapter, we'll only be dealing with binary solutions. Binary solution means there will be one solute and one solvent, right? And
Yes.
how will we differentiate solute and solvent? The You can say the component which is present in larger quantity will always be solvent, and the other one will be solute.
Solid.
Okay. Yes. That's why when we'll be dealing with concentration terms, so since solute is present in larger quantity, so we don't talk about the uh, volume of solute. We talk about we don't talk about the weight of solute or something. We only talk about the concentration of solvent only. Okay.
Okay.
Yes. Then we have types of solute. See, types of solutions. The type of solution, maybe we have three states of matter: solid, liquid, and gas. Okay.
Yeah.
So what we'll do is we'll fix one of the solvent and take all the other states of matter as solute, and we'll classify it. Okay. So in
Okay.
NCRT, if you have the first table 1.1, see, I'm not okay, let me share the screen so that you can see. I'm not writing it. It will just take time. See, if you can see, uh, we have fixed, see, in gaseous solution, we have fixed the solvent as gas, right? And then we are
Yes.
taking gas as solute, then liquid as solute, and then solid as solute. For that,
Yeah.
we are also having one example for each. See, gas ka mixture is very easy. Air is a mixture of gases. It
Yeah.
is a gaseous solution. Gas liquid ka mixture is, you can say, gas
The
liquid ka
mist and
mixture.
fog.
हाँ ये fog है and perfumes हैं,
Uh-huh.
right? That's an example of gas liquid. And gas solid ka, if you have seen naphthalene balls,
Yeah. So,
they just disappear if you keep it out on the
yeah.
table. They disappear. So it is a mixture of solid and gas. Okay.
Yeah.
So that's all for the gaseous solution. Again, what we'll do now, we'll fix the solvent as liquid, and we'll take first gas as solute, then liquid as solute, and then solid as solute. Now, if we are taking liquid dissolved in gas, उसका सबसे अच्छा example is oxygen dissolved in rivers, which is the prime thing for survival of aquatic animals, right?
Yeah.
Yes. Then we have liquid solution. Liquid solution ke we have data examples. For
Yeah.
example, benzene is dissolved in any organic solvent. Ethanol, alcohol is dissolved in water. We have a lot of examples for that. Then we have liquid dissolved in solid. So sugar is a solid. We dissolve that in liquid. That is an example of liquid solutions, liquid solid solution. Then we have solid solution. अच्छा, solid solution में क्या होगा? We'll fix that. How are we giving the name? The name is given on the basis of solvent only. Okay. If you are taking
Okay.
solvent gas, they are gaseous solution. If you are taking liquid solution. And if you are taking the solvent as solid, they are solid solutions.
Solid
Okay.
solution.
Yes. Now, if I'm taking a solid as solvent and I'm dissolving the gas in that, it will be gaseous solution. Uska example is hydrogen and palladium. When you, if you have studied thoda bahut, no, I don't
Yeah.
think in class 11 this reaction has came. If we are making ammonia from Haber's process, so in that hydrogen palladium is used. Hydrogen on palladium is used, right? Palladium is
Mm.
a solid. On that, basically palladium the surface is used to stick hydrogen gas. Okay. For the process,
Okay.
for the reaction to proceed, palladium is used as a catalyst, right? So that
Okay.
is an example of solid solutions. Acha, these questions can come in 1 mark question in MCQs. Okay, that's why I'm just going through it.
Okay.
It gets in your mind. If you forget it, so if you remember the class में कुछ तो पढ़ा था, then you'll get it. Then solid के example, many metals are there. Gold में we have mixtures. Gold में we mix silver or something. That are example of solid solution. Okay. Then we'll have some mathematical term expressing the concentration of solution. We'll having some terms. I'll explain you that. See, uh, for that I need to write. You might have learned in class 11th the molarity. all these are just repeated here. So basically we will be having, I think, 6 to 7, 6 to 7, yes, we are having 6 concentration terms that are uh, molarity. See, I'm starting from the bottom. Molarity. What is molarity?
Okay.
Molarity is basically moles of solute divided by basically if someone asks what is molarity, so you'll be saying ki how many moles of solute is dissolved in the solution. Okay, in 1 liter,
Yeah.
in 1 liter of solution, whatever the moles are dissolved, that is the molarity of the solution,
Molarity.
right?
Yeah.
Remember one thing, the volume which we are taking, there should be in liters only, right?
Yeah.
Yes. Acha, are you aware how to find moles? Moles ke liye we have three
Yeah.
formulas. First one is we take the given mass, divide by the
Molar
molecular
mass.
mass. Yes. And then we have the second formula ki if we are given the volume, so we divide it by 22.4. And the third
Yeah.
one is if we are given number of particles, we just simply divide it by Na.
Yeah.
Right, so those are the three methods which we can find the moles. So molarity will be moles divided by volume in liter. ठीक है, इसी के if we say इसी के parallelly if we see molality, which is
Ma'am,
represented by,
could you repeat the moles formula? I'll just write it down so I
okay,
can
okay,
refer to
I'm
it later.
okay, see, I'm writing here. I thought you might be knowing, that's why I've not written.
I
I'm
know
writing,
it,
see.
but I'll still write it on
Okay,
my
yes,
intuition note.
see, moles is represented by small n, right? The first
Yeah.
one is given mass. Given mass, what is mass? Whatever mass in the question is given, right?
Yeah.
Given mass divided by molar mass. Iska, I'm telling you one example. For example, if in question is said, you find out the moles of 23 grams of CO2, right? So this
Yeah.
23 will act as given mass, which will say like 23 divided by CO2 is carbon 12, oxygen 32, it will be 44. So whatever this value comes will be the mole of this particular
Yeah.
entity, right? And the unit will be MOL. Okay. Then the other formula is if we are given
Volume.
volume and that volume is in liter, so V liter divided by 22.4, and the criteria for the formula to use is uh, the conditions should be standard temperature and pressure. See, there will be two things given. Either it will say the volume of particular gas is this much at standard temperature or pressure, or it will say the volume of this gas is this much at 1 atm and 273 kelvin. Okay, that both are same. Standard temperature pressure is 1 atm pressure and 273 kelvin. Okay, मतलब room temperature.
Yes.
Okay, so this, and the third formula which I was talking about was that moles is equals to number of particles. Now this number of particles could be anything. It could be
Yeah.
molecule, it could be atom, it could be ion, or it could be electrons. Take the number of molecules divided by Avogadro's number, that is Na. So these are the three formulas with which I can assure you can solve all the moles question. Okay?
Yeah.
If you learn these three formulas, you will never get any problem in moles question. Okay? Okay.
Yes.
Yes. So uh, we were seeing molarity. So molarity will be moles divided by V liter. Now, if this volume is not given in liter, simply multiply it by 1000, and this formula can be used for milliliters also. Okay, so
Okay.
rather than I'm explaining you how to convert v liter and divide all these things, simply learn 1000 से multiply कर दो, formula can be changed. So ये formula कैसे derive हुआ है? What happens is कि moles divided by, now to convert liters into milliliter, we divide the volume by 1000. Now this liter, this 1000 now, since it is in division, so when we solve, it goes upside and converts into multiplication. So this formula
Yeah.
is like that only. So if now abhi aage I'll explain you in molality also and in all those things. जब भी 1000 से multiply कर रहे हैं तो यही हो रहा है कि denominator से it is going into numerator. So it will be understood आगे के लिए. एक बार समझा दिया, आगे याद रखना. ठीक? Now Coming to molality, molality will be the only thing जहाँ पे mass of solute की बात हो. But in any of the in the 7 concentration terms which we'll learn, only molality will talk about the mass of solute. बाकी कहीं भी solute की कोई बात, solvent की sorry, बाकी कहीं भी solvent की कोई बात नहीं आएगी, हर जगह solute की ही बात होगी. Okay, because solvent is present in very large quantity and we can simply ignore large quantities ko we ignore it. ठीक, molality will be moles, same, moles of solute divided by weight
Mass of
of,
solvent.
हाँ, weight of solvent या mass of solvent, and it will be in kg. If it is in gram, then simply multiply it by 1000. Okay.
Again, same way.
Yes. So these were the molality and molality. Acha. Remember, actually, let me अभी समझाते हैं वो चीज. So are we clear with molality and molality?
Yeah.
Yes. The next which we have to learn is mole fraction. Acha, you must already know what is fraction. Basically, a part of something divided by whole. ठीक है, तो मोल फ्रैक्शन भी वैसे ही है. Since we are talking about mole, तो जिसका भी मोल फ्रैक्शन you are trying to find out, for example, we have इसमें we are talking about binary mixtures. So there will be two components, A and B, right? So if I'm talking about mole fractions of A, so mole fraction is represented by X. So if I'm talking about mole fraction of A, then I'll say कि moles of A divided by total moles. Total moles will be
A
moles of A
plus
plus
A
moles of
plus
B.
moles of B.
Yes. So this is the simple formula. Acha. We also know that if we are talking about parts and if we're talking about fraction में parts and the sum of all the parts will be 1, right? So I can say
Yeah.
this also कि the moles of A plus moles of B would be 1. Mole fraction of A and
Yeah.
mole fraction of B, the sum would be 1. So if I have to find out the mole fraction of B, it could be found out like this also. Simple
1 minus. Yeah.
mathematics. Okay,
Yes.
this is the formula for. अच्छा, ये वाला formula can also be used. कैसे? Moles of B divided by total moles. But if we are not given with the moles of B, so then we can use this formula. Okay.
Okay.
Yes. So mole fractions भी clear हो गया. Then we will come across parts per million. अच्छा, parts per million, the easy explanation is, for example, you have been given $100, and from that $100, I have taken $1. So that is parts
Okay.
per million. Okay. तो $1 million से you have taken $1, that is parts per million. तो बहुत छोटी क्वांटिटीज में कोई चीज प्रेजेंट होती है, उसको रिप्रेजेंट करने के लिए we take this concentration term. For example, if I'm saying that in 1 liter of water I have added a pinch of salt, so that pinch of salt will be present in very trace amount. To
Okay.
represent the concentration of that pinch of salt, I'll be using this particular thing. Achha, what is the formula for parts per million? Parts per million का formula
Will
will
it be
be,
something
हाँ,
divided by 1 million?
yes, it will multiply by 10 raised to
Oh,
the power 6. Why? Because we are going into smaller units. हाँ, बड़ी units से smaller
okay.
units में जाते हैं, तो 10 raised to the power 6 sorry multiply होता है. Okay,
Okay.
so it will be, for example, if I'm talking about the parts per million of solute, it will be number of components, whatever we are talking about, divided by total component. जिसे परसेंटेज निकालते हैं सिमिलरली वैसे ही, बट इन परसेंटेज, परसेंट मीन्स पर 100, राइट? सो इन परसेंटेज
Yeah.
वी आर मल्टीप्लाइंग बाय 10 रेज टू द पावर 2, मतलब 100 से. नाउ वी आर टॉकिंग अबाउट मिलियंस, तो मिलियंस में वी आर मल्टीप्लाइंग बाय 10 रेज टू द पावर 6. यही डिफरेंस है.
Okay.
ओके. अच्छा, इसी के पैरेलली में आई एक्सप्लेन यू द मास परसेंटेज. तो मास परसेंटेज कैसे हो जाएगा? whatever mass you want to find out. Mass percentage मतलब
Yeah.
जिसका भी mass निकालना है. For example, I have to find out the mass percentage of solute. So I'll take mass of solute.
And then over mass of
हाँ,
solution.
total mass of solution. And since I'm talking about percent means per 100, so multiplied by
Into
100.
100.
Yes. that is mass percentage. Now if I'm talking about mass versus volume, so similarly, rather than writing total mass of the solution, I'll say volume of the solution, total volume of the solution. Okay. And
And then
volume
there's volume percentage.
that is see, we will having three things. We'll having mass percentage, we'll be having volume percentage, we'll be having mass by volume percentage. तीनों का formula is parallel. ठीक है. And we
Yes.
are having parts per million. So parts per million का formula I told you, it's number of components, whatever you find out, divide by total components into 10 raised to the power 6. Since it is million, million में we have 6 zeros. ठीक. Base quantity से. In mass by mass, it will be mass of solute divided by total mass of solution, and since it is percent, multiplied by 100. ठीक. Then similarly for volume by volume, volume of component
Upon
divided by,
total volume.
yes, volume of solution, a total volume, into 100. And this mass by volume, mass of component divided by total volume into 100.
Yeah.
ठीक. अच्छा, so we
Yeah.
have seen, I think we have seen all the concentration terms. So one thing which I need to tell you is, ऐसा क्वेश्चन आता है कि which of the following concentration terms does not depend on temperature. ठीक है. So remember that in whichever formula there is volume in the denominator. So अभी तक हमने क्या क्या पढ़ा? We have studied this thing.
So, ma'am, could you repeat that part? So, whichever component has volume in the denominator, that will be affected by temperature.
Yes, that will be affected by temperature. So this volume percentage, it will be affected by temperature, right? Mass by volume percentage, it will be affected by temperature. Molarity will be affected by temperature, right? These
So,
all
what
will
was
be.
the question? What
The
component is
question
not a...
question was that which concentration term is not affected by the temperature. So
Okay.
molality, small m, mole fraction, mass percentage, these are all not affected by temperature. Okay, it is a very famous question. Why scientists use molality in place of molarity? Because it is not, basically it is not affected by temperature. That's why. Simple answer is that. Okay. Because volume depends on temperature, and because volume में expansion or contraction हो जाता है, but mass is a basically you can say constant quantity. It does not change with place. तो इसीलिए these things are not affected by temperature. Okay, the reason for that is this. Clear? Are we clear with concentration terms? Asha, do you want to do any questions from the exercise, or we can proceed?
I think this part is fine, but as we go to
Non-ideal
uh,
solutions,
the
colligative properties.
deviations and the colligative properties, it gets
Yes,
confusing for me.
yes, that's confusing. So, yes, so basically, it is very easy. Class 10 से पढ़ के आ रहे हैं. उसके बाद we are having solubilities. So we already know like, dissolve, like. Do you want me to explain this, or वहीं चलें colligative properties पे चलें सीधे?
Can you go from I think there was like positive, negative deviation,
हाँ,
ideal
let's
solution.
go to ideal solutions. Ideal solutions पे चलते हैं. All these are very easy. You read once, and if you get any problem, I'll explain you. ठीक है?
And
Henry
that
laws.
volume by mass, Raoult's law and all is there, right?
Yes, Raoult's law is there.
Yeah,
So
that's all
let me
fine.
explain.
That's
That's all
all
fine to
okay.
you?
That's all
Okay.
okay. Okay,
Yes.
okay, it is.
So, do you want me to explain it, or you will once read it and get clear?
Um, okay, you explain it because I don't think I'll be able to understand.
Okay. Let's first read. We have solubility, yes, the solubility में like dissolve like, first the NCERT explains कि like dissolve like मतलब if we are having organic solvent, organic solute, that organic solute will be dissolved in organic solvent only and non inorganic solvent will be dissolved. For example, if I'm trying to dissolve example, let me see if any of the example is given. For example, polar solvent मतलब जिसमें charge होगा, naphthalene and all these things will not be dissolved in water, they'll be dissolved in
Organic
organic
solvents.
solvent only. And sugar, sodium chloride, these all, this won't be dissolved in organic solvent, will be dissolved in water only. तो इसी को example बना के NCERT has said कि polar solvent dissolve polar solute and non polar solvent dissolve non polar solute. ठीक, like dissolve like, unlike dissolve unlike. अच्छा, now we also know कि solute and solvent मिला के solution बनाते हैं. So when we start adding the solvent, when we start adding solute into the solvent, एक stage ऐसी आती है where no more solute can be dissolved. But the
Okay,
condition,
yes.
is that the temperature is fixed. For example, at 25 degree, I have taken a glass of water, okay, and I have added 4 tablespoons of sugar. Okay? Now I'm
Okay.
not changing temperature and no more sugar can be dissolved. So this solution will be called as saturated solution. Like, right?
Mm.
The condition, the only condition is that temperature must be fixed. But if I increase the temperature, if I boil this thing, this solution, so more sugar can be dissolved very easily. इसका सबसे अच्छा
Yeah.
example है when we make, if you have ever made the juice at home, शरबत बनाते हैं घर पे, तो हम
Mm-hmm.
लोग we don't take the fridge वाला पानी, we take, either we take the water directly from the RO, or what we do is we take हल्का सा गुनगुना पानी, थोड़ा टेम्परेचर बढ़ा के पानी का.
Mm.
तो in that case dissolution becomes easy because the temperature is
Okay.
raised. ठीक?
So
So
you can
basically,
dissolve more.
yes, it dissolves more. So if we increase the temperature, तो वो saturation खत्म हो जाएगा, फिर और sugar dissolve हो जाएगी. That's why एक चीज जो saturated solution की temperature में लिखी हुई है कि a solution in which no more solute can be dissolved at the same temperature and pressure, it is called a saturated solution. ठीक?
Okay.
Yes. Okay. Now then we are having what is the effect of temperature on solubility? So obviously, if
More the temperature, more the
yes, more the
solubility.
solubility. Yes, liquid
Okay, that's
solubility of solid in a liquid, particularly if you're talking about solid, if you're dissolving anything in liquid, solid in a liquid, उसके केस में टेम्परेचर बढ़ाने पे solubility increases. Okay, and pressure के लिए भी same thing, pressure बढ़ाने पे भी it will be increasing. ठीक है?
okay.
अच्छा, प्रेशर का कोई इन सॉलिड्स प्रेशर का कोई इफेक्ट नहीं आता है. प्रेशर का मेन इफेक्ट यू विल सी इन गैस ओनली. ठीक? सो
Okay.
यहाँ से व्हाट यू हैव टू नोट इज, रिमेंबर दिस थिंग कि what happens कि in Lee-Chatelier principle कि if the reaction is endothermic, endothermic में क्या होता है?
The heat
Heat
is
is
absorbed.
absorbed. Yes. So when the reaction is endothermic, we increase the temperature, so the solubility increases. Okay.
Yeah.
But if the reaction is exothermic, the heat is given out and we are increasing the temperature, तो उससे solubility decrease हो जाती है. So in order to comment on the solubility of any reaction, we must first get it know कि वो endothermic है या exothermic है. ठीक? और ये चीज आपको क्वेश्चन में दी होगी in either of the form. Either it will directly say कि the reaction is endothermic, or it is the reaction is exothermic, or it will say delta H is greater than 0 or delta H is less than 0. Delta H greater than 0 का मतलब क्या होता है? Reaction is endothermic, मतलब the heat which the heat of the solution is greater than 0, मतलब it is absorbing the heat. And if the heat of the solution is less than 0, it means the reaction is giving out heat. ठीक?
Okay.
Delta H
So
is
if
basically
it's
enthalpy.
so basically if we increase the temperature, it will be exothermic.
Yes. No. I'm
Okay.
not saying that. See, for
Okay.
example, if you have seen NaOH, if you have ever been in lab in class 11,
Yeah.
so NaOH को when we dissolve in water, so जिस भी कंटेनर में हम उसको डिसॉल्व करते हैं वो कंटेनर गर्म हो जाता है,
Yeah.
heat is evolved, so this reaction is exothermic. ठीक है. अच्छा,
Yeah.
एक्सोथर्मिक है, तो अब यहाँ पे इफ यू इंक्रीज द टेम्परेचर तो सॉलिबिलिटी डिक्रीज हो जाएगी. क्यों? क्योंकि एक्सपेरिमेंटली इट हैज बीन सीन कि व्हेन इन एक्सोथर्मिक रिएक्शन व्हेन टेम्परेचर इज इंक्रीज सॉलिबिलिटी इज डिक्रीज. ये कैसे देखा गया है? इट इज बेस्ड ऑन द ली चैटलियर प्रिंसिपल. व्हाट इज ली चैटलियर प्रिंसिपल? अभी जब केमिकल काइनेटिक्स हम लोग पढ़ेंगे तो यू विल गेट टू नो. ठीक,
Mm.
राइट?
Yes, ma'am.
तो NaOH का example is exothermic. On the other hand, dissolution of sugar in water is an endothermic reaction. तो उसमें whenever you will increase the temperature, तो solubility will increase. ठीक?
Yes. Okay.
Okay. Now temperature and pressure. Pressure का solids पे कोई effect नहीं होता है. ठीक? So there is no significant effect on solubility of solid in liquid of pressure because solids are highly incompressible. उनपे प्रेशर का कोई असर नहीं होता. ठीक.
Yes.
Yes. So next thing which we have to talk about is solubility of gas in liquid. अभी तक we were talking about solubility of solid in a liquid. तो solid में हमने देखा कि टेम्परेचर का इफेक्ट तो आ रहा था. टेम्परेचर का इफेक्ट वाज दैट कि if the reaction is exothermic the solubility was decreasing, and if the reaction is endothermic the solubility was increasing if we increase the temperature, and pressure has had no significant effect, right?
Yeah.
Then moving to solubility of gases in a liquid, this is basically controlled by Henry law. What this says is the solubility of gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of the liquid or solution. क्या होता है? See, we are having a solution, okay, and in that we are having a gas. Okay? So basically, it is a gaseous mixture.
Yeah.
What the Henry law says that whatever is the you can say solubility, how much this gas will be soluble, that will be dependent directly proportional to the partial pressure of this gas. Which gas? Whatever gas is present on the surface. Okay, it will be directly proportional to the partial pressure of that gas. ठीक. अच्छा, it
Okay.
has also been experimentally seen that the partial pressure is proportional to the mole fraction. Okay, because partial pressure is a little difficult thing to calculate, so partial pressure is directly proportional to the mole fraction. So we can say that the partial pressure of the gas. अच्छा, solubility तो कोई ऐसी quantitative term तो है नहीं कि this is that much एक कंपैरेटिव है ना कि this is more soluble, this is less soluble. तो उसके लिए
Yeah.
हम कोई मैग्नीट्यूड नहीं यूज कर सकते. तो rather than using solubility we take the partial pressure. तो हमने कहा solubility is directly proportional to partial pressure. This was equation number 1. ठीक है. और बाद में we have seen that partial pressure is directly proportional to mole fraction, right? So if we calculate the partial pressure of the gas, so we can say कि how much a soluble gas is in something, right? तो हम लोग
Yeah.
partial pressure calculate करके बताते हैं कि how much any gas is soluble in liquid rather than calculating its solubility. So Henry gave this law. तो अब for mathematical thing we need a formula. So to remove this proportionality constant, remove this proportionality sign, एक proportionality constant आता है kh, that is known as Henry law. Henry's constant or Henry constant हर gases के लिए you will be given. So P, partial pressure of the gas, is equals to khx. Okay.
Okay.
And also it has been experimentally seen that whenever we plot this graph it will come at straight line. Why it will come at straight line? See, if we compare y is equals to mx, right?
Mhm.
ये
Yeah.
straight line की equation. अच्छा, straight line की equation देखो, you'll get two straight line equation. We have two equations that represent straight line. y is equals to mx plus c, and we have y is equals to mx. Why I'm explaining you this? Because abhi when we study negative deviation, positive deviation and all these things, तो वहाँ पे graph का थोड़ा सा use आता है. तो quickly I'm explaining you. We have two equations that represent straight line. If we're talking about this equation, तो यहाँ पर इस equation का मतलब ये होता है कि the line is passing from origin. मतलब
Yeah.
एक्स एक्सिस पे कट नहीं कर रही है. बट इफ वी आर टॉकिंग अबाउट दिस इक्वेशन, तो इसका ग्राफ कुछ ऐसा बनता है, थोड़ा सा ओरिजिन से ऊपर. मतलब यहाँ पे वाई एक्सिस पे देयर मस्ट बी सम डिस्टेंस.
Yeah.
दिस सी इज द वैल्यू ऑफ दैट, उसको इंटरसेप्ट कहते हैं. दिस सी इज द वैल्यू ऑफ दैट इंटरसेप्ट. ओके.
Yeah.
So if we compare the Henry's equation, it is compared to the second equation, y is equals to mx. So the graph of Henry's equation is this. Okay. So in your exam, in very short answer question, it could be asked to define Henry's law and draw its graph. So you simply write that partial pressure of the gas is directly proportional to its mole fraction, and experimentally it has been proved that the straight since p is equal to, acha, remember, whenever the definition of any law is asked, if we have a mathematical format for that, always write the mathematical formula. Don't forget to write the mathematical formula. Okay.
Okay.
So if you have been asked about the Henry's law, so you'll write the definition and then you'll do like this only. If P is the partial pressure of the gas and X is the mole fraction, then P is directly proportional to X. Then you'll write like this. If P is directly proportional to X, then so it can be written as P is equals to KHX, where KH is the Henry's constant. On comparing this equation number 1 with straight line equation, we get a straight line that passes through the origin, and draw this graph. Your question is completed. Okay. So in very short answer question, if this comes, we have to write all these things. Okay?
Yes.
Because we have to show the examiner that we know the definition also, and we also know the formula. Okay? So ये सब चीजें लिखनी पड़ती हैं. Okay. Now for different gases, we have different values of KH. जिसका value is given in the table. Acha, if you see in the table कि the solubility of the gases, yeah, the value of KH, it increases with increase in temperature, right?
Yeah.
If we are increasing the temperature, in the table if you see, if we are increasing the temperature, the value of KH increasing, and if the value of KH is increasing, then this partial pressure thing will also be increased, because if this value will be increasing, तो partial pressure भी increase करेगा. Partial pressure increase करेगा तो automatically solubility भी increase करेगी, right? So we can say that कि the solubility of the gas increases with increasing temperature, right?
Yeah.
Yes. So this is clear. Acha, this is the reason कि okay, एक मिनट, थोड़ा सा कुछ गड़बड़ हो रही है. Solubility of gases increase. Sorry. उल्टा बोल दिया. If you'll see the temperature, so as the temperature is increasing, the value of KH is decreasing. Sorry. ये तो मैंने कहा कि यहाँ कुछ गड़बड़ हो रही थी. See the table. If do you have your NCRT? Do I
No,
need to
it's
share?
not with me.
Okay, let me
I'll
share
go
the
get
screen.
my NCRT.
No, wait, let it be. I'm sharing the screen. अगली बार से लेके बैठना, okay?
Okay.
See, if you see this table, which table I was talking about, this table, right? So at 293 Kelvin, या हाँ, oxygen की बात करते हैं. At 293 Kelvin, the value for KH of oxygen is 34.86, and if we have increased the temperature, the value of KH is 46.82, right?
Yeah.
Yes.
So it is
So
increasing.
yes, it is increasing, and sorry. Yes. So basically, the table says that KH values for both nitrogen and oxygen increases increasing temperature, indicating that solubility of gases increase with decrease in temperature. Acha, why it is saying that? Because let me see, KH के साथ inversely proportional हो जाएगा फिर. ये तो directly proportional होना चाहिए. partial pressure of the gas is directly proportional to the solubility. Okay, partial pressure is directly proportional हो गया. And KH, Henry's constant, is increasing with increase in temperature. These gases increase in temperature, indicating the solubility of gas increases with decrease in temperature. 293 Kelvin पे 334.86 था, 303 पे it is 46.82. नाइट्रोजन के लिए भी 276.88. So why it is saying that increase in temperature? एक minute. Let me write the formula. Let us crack this thing. If yes, confusion is. We have learned that partial pressure of gas is directly proportional to solubility. Okay, and we have also learned that partial pressure is directly proportional to the mole fraction. Okay, and the partial pressure is equals to KHX. It is a constant. Okay, now if constant is increasing, see, ऐसे 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 क्रैक करते हैं. Pressure is directly proportional to this thing,
Mole
mole
fraction.
fraction. ठीक? And I have written P is equals to KHX. ठीक है? Now if we see KH is equals to X upon P, right?
No,
Now
P
this
upon X, right? Oh no, X upon P.
X upon
No,
P
it's
upon
P
X,
upon
P
X.
upon X, P upon X. Now I'm saying if we are increasing the temperature and KH is increasing, this means this whole value is increasing, right? If left hand side is increasing, so obviously right hand side is also increasing because equal to है. Now if this thing is there, इसका मतलब either the numerator is decreasing or the denominator is increasing, right?
Yeah.
अच्छा. And also we know that mole fraction is a fixed quantity. Mole तो change होता नहीं है temperature के साथ. So it means कि temperature के साथ partial pressure is changing, right? तो
Yeah.
partial pressure क्या हो रहा है temperature के साथ कम हो रहा है, obviously if KH is increasing.
Okay.
ये समझ में आया? देखो, let me explain you again. What I'm saying is, धीरे धीरे
So
सुनो.
partial, you're saying partial pressure will definitely increase
Definitely
because decrease.
See why? Let me explain you again. First I have said कि KH is increasing. ठीक है? KH is increasing with increase in temperature. Clear?
Yeah.
This is the
Yeah.
एक thing. ठीक है? अब I have said कि since left hand side is increasing, तो right hand side should also increase क्योंकि equal to
Yeah.
लगा हुआ है. अच्छा, right hand side को increase करने के दो तरीके हैं. Either P will decrease, न्यूमरेटर छोटा होगा तो फ्रैक्शन बड़ा होगा, या x बड़ा होगा न्यूमरेटर बड़ा होगा.
Okay.
ठीक है? Now this is a fixed quantity. क्यों? मोल्स तो चेंज होते नहीं है किसी भी कंडीशन में. मोल्स इज अ फिक्स्ड क्वांटिटी, सो डेफिनेटली प्रेशर इज डिक्रीजिंग, right? Now if pressure is decreasing, so solubility is also decreasing since pressure and solubility are directly proportional. अब समझ में आ गया?
Yeah.
So
But
that's why
initially I was thinking it was because it's directly proportional and inversely
हाँ,
proportional. So that
so
way.
yes, that's what that was all I also thinking. But since we are talking about KH, तो अभी जब हम लोग डायरेक्टली प्रोपोर्शनल की बात कर रहे हैं तो KH इज अ कांस्टेंट. बट नाउ अभी वी आर टॉकिंग अबाउट वेरिएशन ऑफ KH, तो हमें KH को वेरी करना पड़ेगा, KH के साथ और वैल्यूज भी वेरी होंगी, ये करना पड़ेगा. गॉट इट?
Okay. Yes, sir.
So now since the value of pressure, partial pressure is changing with temperature, तो इसीलिए solubility is also changing. इसीलिए it is said कि जो मछलियां होती हैं, the aquatic animals, they survive in cold water rather than warm water. क्योंकि टेम्परेचर बढ़ता है तो solubility decrease होती है. Solubility decrease होती है तो ऑक्सीजन की कमी हो जाती है. Okay?
Yeah.
So this level of dissolved oxygen get decreased. That's why they are not able to survive in cold water, warm water. Check.
Yes, sir.
Now we have several applications of Henry's law. That is a purely theoretical topic. You once read it, you'll get clear to it. ठीक है, उसका कोई ऐसा as such explanation नहीं है. It is just कि to increase the solubility of carbon dioxide gas we take high pressure. ठीक है, क्योंकि high pressure पे solubility increase हो जाएगी. स्कूबा डाइवर्स में जब हम स्कूबा डाइवर्स की बात करते हैं, सो स्कूबा डाइवर्स व्हाट दे डू इट, वो धीरे धीरे बाहर आते हैं. क्यों? अगर अचानक से टेम्परेचर चेंज करेंगे तो उनकी जो वेन्स होंगी वो फट जाएंगी, क्योंकि उतना तेज प्रेशर का डिफरेंस दे आर नॉट एबल टू मैनेज. ठीक, दैट इज प्योरली अ थ्योरेटिकल टॉपिक, देयर इज नथिंग टू एक्सप्लेन इट. हाई एल्टीट्यूड्स में अच्छा, हाई एल्टीट्यूड्स में पार्शियल प्रेशर ऑफ ऑक्सीजन इज लेस, दैट्स व्हाई वहां पे थोड़ा कभी कभी ऐसा कंडीशन आ जाता है एनॉक्सिया के. व्हाट इज द कंडीशन फॉर एनॉक्सिया? द कंडीशन फॉर एनॉक्सिया इज दैट कि कमजोरी आने लगती है, वीकनेस आ जाती है, और थोड़ा ऑक्सीजन का सप्लाई दिमाग में कम हो जाता है, तो इसलिए दे आर नॉट एबल टू थिंक प्रॉपर. ठीक है,
Okay.
so these are the applications of Henry's law. Then we have effect of temperature. Solubility of gases in liquid decrease in increase of temperature. अभी हमने ये देखा ही, देख के आए हैं पूरा explanation, right?
Yes, ma'am.
Okay. Okay, then we have, अच्छा, I'll in the next class I'll explain you the Lee Chatelain principle अच्छे से एक एक करके. Then we have
Okay.
vapor pressure of liquid solutions. अच्छा, do we have 5 minutes time? ठीक है, let us quickly do. अच्छा, what is volatile liquids? Volatility means basically how fast uh, the our solute is changing into vapor. ठीक है, volatile मतलब
Okay.
कि how fastly, या how volatility is basically ability to change into pressure, vapor. ठीक,
So the
तो क्या
ability to change into pressure
vapor
is
vapor
quick. Vapor is
yes.
quickly.
Quickly see, if I'm saying
If it's
volatile and non-volatile मतलब it is not changing into vapor. Volatile मतलब it
okay,
is changing into volatile, it is changing into uh,
to vapor.
vapor. Now if I'm saying more volatile, तो इसका मतलब it is changing more fast into vapor. If I'm saying less volatile, तो इसका मतलब वो धीरे change हो रहा है. ठीक है, मतलब
Okay.
clear?
Yes, ma'am.
Yes. Okay. So basically अभी तक हमने, देखो हमने पहले पढ़ा था, इस चैप्टर में we'll be dealing with liquid solution. ठीक है, अब liquid solution में 3 liquid solution थे. We have dealt with solid in liquid, we have अभी dealt with liquid, gases in liquid. अब we'll deal with liquid in liquid. ठीक है,
Okay.
liquid in liquid में we'll come across ideal solution, non ideal solution, all these things. That is our
Yeah.
main aim. तो we'll study of liquid solution. अच्छा, लिक्विड सोल्यूशन कब होगा? जब सॉल्वेंट और अच्छा सॉरी, जब सॉल्वेंट इज लिक्विड एंड दैट सॉल्यूट इज आइदर लिक्विड, गैस और एनीथिंग. ठीक, लिक्विड सोल्यूशन की 30 कैटेगरी थी. अच्छा, अभी जो वट एवर वील स्टडी कि वेपर प्रेशर ऑफ लिक्विड लिक्विड सोल्यूशंस, तो उसमें दोनों चीजें लिक्विड होंगी, सॉल्यूट भी और सॉल्वेंट भी. ठीक है, तो लेट अस
Okay.
कंसिडर अ बाइनरी सोल्यूशन इन विच वी हैव टू वोलेटाइल लिक्विड्स. वोलेटाइल लिक्विड्स मतलब दो हमने सॉल्यूट लिया और सॉल्वेंट लिया है, बोथ हैव द एबिलिटी टू चेंज इनटू प्रेशर, sorry, change into vapor. ठीक है, so
Okay.
we are taking two volatile liquids, liquid 1 and liquid 2. It means both these both are volatile, it means both have the ability to change into vapor. ठीक,
Vapor.
okay. Now what I have done is अच्छा, I'm not. Achha, we have just 3 minutes left. Rather than
Okay.
starting a new topic, this topic will start in the next class. ठीक है, क्योंकि अभी I
Okay,
also
ma'am.
have a class at just 7:30. Whatever we
Okay.
have studied today, is that clear to you?
Yeah, it's very clear to
Achha,
me.
are you okay with my teaching style, or is there anything you want to change?
Not really right now, but I would like you to ask me more questions in the middle so
Okay,
that
ठीक है,
I
तो okay. Then in the next class, I'll